Hi Bio4 and welcome to part 2 of vessels, of blood vessels. So we finished up here comparing arteries, arterioles, capillaries. Now we're going to move on to individually look at a little more detail about these. So when we're talking about arteries, we're going to differentiate mostly by size. So we label conducting arteries, also called elastic arteries. We give that name to those that are large. They're the largest arteries that we have. So think of something like the brachial artery. Okay, it's a conducting artery. It has a lot of elastic fibers in it. It has a high density of these elastic fibers. And what that is going to allow it to do, it's going to be able to recoil. So imagine sort of a balloon, a water balloon that you inflate and then you let the water go out. It's going to have recoil, right? The water balloon is going to go back to its original size. So it acts as a pump. So if you think of the aorta, the common carotid, the brachial, subclavian, these large arteries are going to fill with blood. And then when that ejection of blood from the heart drops a little bit, right, because that ejection's already happened, the heart's already pumped, it's going to drop a little bit as the heart relaxes, then those arteries are going to recoil again, and they too are aiding in the pumping of that blood, making it move forward. So they are conducting. They're conducting arteries. They're also elastic arteries. So both those names are used. This is a picture of that, right? If you imagine a pulse coming through, it's going to stretch this out. It's going to scoot that out in this direction and sort of blow it up. And then once that blood has gone through, it's going to retract back down again and move the blood along. So they really are a second little pump. All right, so let's differentiate those from arterioles. So these are arteries also. They're slightly smaller, and we're going to call them distributing arteries or muscular arteries. And they have a lot of muscle fiber in their tunica media. So less so of the elastic and more so of the muscle. And what they're going to be able to do very efficiently, and we want them to be able to do that, is to vasoconstrict and vasodilate, which means reduce the radius of that vessel or increase the radius of that vessel. So here I have the brachial listed, but really the brachial maybe can be thought of as both a distributing and an elastic. So I would never make you differentiate that in a test. So let me show you in a diagram. You have something like this. So you have vasoconstriction, where it's just becoming narrower, and vasodilation, where it's dilated out. And notice how many of these red blood cells are exiting. So fewer cells exiting when you vasoconstrict, many more exiting when you vasodilate. So it's going to increase the flow. So this is necessary when we want to increase the flow to a muscle that's exercising, when we want to increase the flow to a digesting region of the brain and then of the intestine, and then vasoconstrict when you're going to limit blood to a certain area. So let me backtrack here. We're talking then about a type of artery or small artery that is able to use its muscle to either close up the lumen or open it up. Okay, those are distributing. And then we have smaller arteries. We're going to call them resistance arteries. And these are the much smaller ones. These are less than 0.5 millimeters in diameter. In other words, pretty tiny. And, you know, they don't have a tunica interna that's that well defined. They have some muscle cells, and with those few muscle cells, they're still able to vasoconstrict a little bit and vasodilate. So this is kind of a, gross generalization, and just think of them as being able to either pump or vasoconstrict and vasodilate depending on their size. Okay. This is a condition, an aneurysm. It's interesting to talk about right now, because what happens if those vessels become fragile? And for whatever reason, because usually we don't know what the reason of that fragility is. But if you had a vessel all of a sudden that has a weakness in this area and it were to balloon out when the pressure increases, this could be dangerous because something like this could happen. It could actually rupture and then you have bleeding. This is called a saccular when it forms a little sac. This is called fusiform when it sort of expands on both ends, and indeed like a water balloon, right? So these could happen at the base of the brain or at the abdominal aorta, which would be very tricky. That can be fatal if not caught, and it's not something that's easy to catch. If the person feels faint all of a sudden, drops, you don't know what's happening. You don't know that there's been bleeding, there's been internal bleeding. So that's what an aneurysm is. Next, what we want to move on to is naming all these arteries. This we're going to do mostly in lab. And next week you start with looking at those. So I just wanted to give you sort of a general idea. We're going to learn only the major arteries. And we're going to learn those here in the chest and then coming down into the abdomen. So the major arteries of the trunk, then you imagine the heart here, the aorta, and then those arteries that are coming down either into the arm or into the head. So we're going to learn the names of these arteries. And I'm going to come back to that one. And let's stop there. I'm going to come back and stop right here in the arterial system, and we'll start next time where I can start giving you the specific names of the arteries that I want you to know. Okay, thanks for listening in. Bye.